My name is Simon Schaffer. I teach history of science at the University of Cambridge in England. We're in a bistro in the 11th arrondissement of Paris on a sunny spring day. So I study scientific practices, the work of scientists in culture as it's developed since the 17th century. I'm particularly interested in the more exact sciences, experimental physics, astronomy, meteorology, climatology, chemistry, because those sciences involve the use of typically very complicated arrangements of apparatus and of personnel, very often in specially privileged sites, and they demand the construction of short-range control over those sites and of long-range networks which link those sites together. So I've written about experimental science as it emerged in early modern Europe, on the creation of a public for the sciences during the Enlightenment of the 18th century, and the general development of astronomy and of physics and of, broadly speaking, cosmology between the early modern period of the 17th and 18th century and high modernism in the 19th and early 20th centuries. Yes. One assumption we make, I think, about the sciences is that what's to be explained, what's puzzling, is when people differ, when they disagree. Because I think a very widespread assumption, and it's an assumption that I reject, is that the default condition, the natural state of the sciences is consensus, agreement. So that the idea is that when experts disagree, something strange must be going on. Something political, ideological is distorting what goes on in the sciences. My work has adopted exactly the opposite perspective. What I'm interested in is how it is that people, groups of people, come to agree about what is the case about the world, about what nature is like, about what the facts of the matter are. And what that approach does is to make scientific projects intrinsically political. As we've argued in some of our work, the solution to the problem of knowledge is the solution to the problem of order. What that rather strange phrase means is that the problem of knowledge, which is the production of agreement, authority, credibility, trust, works in the same way and is intrinsically tangled up with the production of authority, order, agreement, and consensus. So in some of my work, for example, what I've tried to analyze in detail is the production of facts about what the air is like, the difference between different kinds of gases, the chemical properties of substances. And what fascinates me is that in the 17th and 18th century, there is very wide disagreement between lots of different practitioners about what the air is, how it works. Is it homogeneous or heterogeneous? Is there more than one kind of air? What's the relation between air, breath, and life? There were huge debates about these questions amongst experts, but also in the wider public, because air was understood as having medical significance. Clean air was understood as absolutely crucial for good order, for what were called the questions of police, of public policy. And so there's a politics intrinsic to, even as apparently esoteric and specialist a science as, say, the chemistry of air. So a lot of the work that I've tried to pursue doesn't see questions of politics or ideology or religion as something completely separate from questions about nature and facts and evidence. And it's, I think, the role of the history of science to show how those features of everyday life interact with each other productively. So during the 17th century, it seems to me, on the basis of my work, that a whole series of new institutional practices and new regimes of knowledge begin to emerge. And in contrast with the preceding epoch, I think we can identify at least three major kinds of rupture. One is based around what we might call the personnel of the sciences. We see the emergence of new kinds of institutions, scientific academies, scientific societies, institutions of teaching and of inquiry, which want to single out a new group of persons who, so it's claimed, are unusually reliable bearers and producers of knowledge. They are distinguished by social rank, so they are gentlemen and not merely scholars. They are bourgeois. They are distinguished by sometimes the comportment of their own bodies. This I always find fascinating. We see the emergence, for example, within the new regimes of experiments on one's own body, because it was argued that the body of these people was peculiarly reliable. Its responses to stimuli were peculiarly indicative. So one would use one's own body, in a sense, as a scientific instrument. Its responses to changes in temperature, or to heat and cold, to smell, to noises. Its use of instruments of measurement became a privileged source of authoritative knowledge. And that, in a certain very interesting way, set this group of people apart. But above all, it seems to me, what matters is the importance of experiment itself, the regime of experimental philosophy, as it was called. What was involved there was a series of what I think we can call technologies, practical techniques of knowledge making, which were precedented. They'd been pursued in earlier ages, but now they were formalized, institutionalized, and, even more importantly, extended globally. They involved, first of all, the use of machinery, of scientific instruments and apparatus to extract information from nature, which, as some philosophers of the period argued, was like torturing nature, putting nature to the question, as it was said. Secondly, it involved new kinds of writing, the way in which accounts of what happened during an inquiry had to be written in a very specific kind of way. Ideally, so it was said, so that others could repeat the trials, the experiments, that one had performed oneself. And even if they could not repeat those experiments, they could at least believe that what you were saying you did and saw was true. So there's a kind of what we've called virtual witnessing. When you read an account by a 17th century experimenter, it's as if you're seeing the event yourself. And that becomes a very important claim for authority and trust and credit. And then thirdly, perhaps most importantly, these techniques are supposed to extend globally. This is the period when, at least in Western Europe, in Spain, France, the Low Countries, and Britain, we see the emergence of unprecedented global empires, global commercial, political, and religious systems, which go along with massive accumulation of goods, of objects, of things brought from elsewhere that are going to be subject to intense, exquisite scrutiny. And that scrutiny itself becomes experimental. So a new kind of science emerges that I think we should call inventory science. The science that asks, what is there in the world and what is it made of, such that we can profit from it? So there's an intimate relationship between the new European global networks. There had been global networks before, but now they would be managed by these agents, and the new experimental science of the 17th century. In early modern Europe, a notion of nature emerges, which seems to me to be fundamental, not just for the subsequent development of the sciences, but also for definitions of the relationship between human beings and the world in which they live. It has several absolutely crucial aspects. Perhaps the most important aspects are two. The first is that it's argued from the 17th century onwards that nature is really not what it seems to be. That what there really is in the world, so it begins to be said, is a very restricted range of qualities. And most of what we see in the world is not really there. It's like a kind of poison pen letter, one might think, in which one is suddenly told that things are not as they seem, and deeply hidden behind appearances there is a simpler, darker, more powerful truth, and it's the truth that the sciences, above all, can reveal. So the idea is that what there really is in the world is matter moving. Hard particles banging into each other at known speeds produce all the phenomena we see in the world. And the smells and tastes and colors and all the feelings that we have are, in a fundamental way, inauthentic. They aren't really there. So there is, as a great philosopher has argued, what's been called a bifurcation, a split between the world as it seems and the world as it really is. And that means that nature takes on a kind of double meaning, in which there is the nature which is the subject of inquiry, the nature, the world with which humans interact, and then there is a nature which is revealed by that privileged interaction, which, although it explains, allegedly, the world that we see, is certainly not the same as it. And it's for this reason, so it was beginning to be argued, that it's necessary, as it were, to torture the world. Because the world has to be made to reveal what it's really like. The world is understood as deeply deceptive in a certain way. And I think that's a very profound notion. Closely related to that is the second aspect of this new model of nature, which is related to the idea of what some call maker's knowledge. That is to say, in the 17th century, it begins to be argued very influentially that what we know is what we make. That we only know with absolute certainty stuff that's built. So why is that? Well, that's because if we make something, we see how it is put together. We see its origin, we see the materials out of which it is made, so we can describe it perfectly. And what this did was to license the idea of what was called in the 17th century mechanical philosophy. That's to say that the world is essentially a vast array of machines. And if it isn't a vast array of machines, the best way of describing it is as if it were a vast array of machines. Now, there's obviously a problem there, which is that nature itself was not made by humans. So the claim begins to be made that since God, the creative principle, made the world, the nature that the sciences understand has, as it were, to retrace the steps through which the world was created. There is a kind of recapitulation of Genesis. This is absolutely explicit in some of the great writers of the 17th century. It's clearly there in Francis Bacon and in Isaac Newton, for whom the created quality of the world demands that inquiry into nature recapitulates the processes by which the world came into existence. And obviously what that means is that the status, the standing of those people who can interpret this process of production becomes a religious vocation. Not in the sense simply of reading the book of nature, now that's a phrase that's often used, but of recapitulating the process by which the book was written. And that in turn leads to a notion of nature as simultaneously moral, because we can learn from the way in which nature functions, but also a target, in that we have to take nature apart into its building blocks and then recompose it in order to understand how it works. And then finally, what that leads to, I think during the 18th and early 19th centuries, is a move from inventory science, which is the question, what is there in the world and how is it made, to a new kind of science, which I think we should call analytic science, invented here in Paris between 1789 and 1848, and then copied everywhere else in Europe. A science that says, if we can describe the process by which nature is decomposed, we can recompose it. If we can master analysis, we can achieve synthetic science. And this is obviously related to the coming of industrialization. Industrialization pushes on analytic science and demands synthetic technology. And it seems to me that's a fundamental relationship in what we could call the industrialization of nature. So there's a profound relationship between mechanical nature, industrialization, and the development of a whole range of other sciences, since the claim is that to understand the world scientifically is to analyze it and, in principle, recompose it. And this becomes not simply a method, but a profound ideology for the claims of the sciences, the kinds of objects, precisely, that the sciences manufacture. So in the 18th century, European instrument makers, artisans, engineers build models of the universe. Literally, they build models of the universe, which are designed to show the rationality of creation, by which is meant the way in which the universe can be rationally understood through the artificial production of machines and the effects of machines. An extraordinarily rich and eloquent example of this is the figure of the automaton, the machine that imitates living performances. Now, there's a very interesting relation there between the idea that it's possible to make a machine that behaves like a living being and the idea that living beings are nothing more than incredibly complicated machines. So already in the 1600s, a figure like Robert Boyle, Anglo-Irish chemist, experimental philosopher, and aristocrat, describes nature as a pregnant automaton, by which he means a machine with other machines inside it, with other machines inside those. It's almost a kind of fractal vision of the world, in which at each level of creation, machines contain mechanical components, a pregnant automaton. And that idea becomes extremely widely distributed, not only in theory, but in practice. That is to say, not only in the way in which machines that successfully, more or less, imitated living behavior are in fact built in the 1700s, but also the idea that that provides the paradigm for what it is to understand, as they would have said, human nature. To understand human nature, it was argued, is to understand the springs which drive humans and other living beings. And spring there, at least in English, has a wonderful double meaning, because it means the source, as in the source of water, but it also means the mechanical device that drives the machine, that drives the clock. So philosophers, priests, experimenters, government administrators, statisticians begin to accumulate data, evidence, models that will unlock the springs of human and social systems and understand them as though they were part of the natural system. So in that sense, there's a profound relationship between industrial culture, political culture, and what we might call mechanical science. It seems to me that a very common image of the sciences is that they rely on skepticism, as though the authority of the sciences comes from the fact that at last here we have an institution that is prepared to doubt and challenge and commit itself to a certain kind of critique. In fact, surely one of the most important developments in 17th century Europe is not the institutionalization of doubt, but the institutionalization of trust. That is to say, the definition of groups of persons who are trustworthy, who are credible. Again, the English language is very eloquent here. The word credit relates simultaneously to finance and to knowledge. It begins to be used in that broad range of senses from the late 1600s through the early 1700s. So wonderfully, the first use in English of the word credit to mean the positive side of a financial account is by Daniel Defoe in Robinson Crusoe, the great, if not heroic, myth of the bourgeois individual in a self-generated island economy. What's the importance of credit and trust for public knowledge? It's profound, because what's at stake here is that it begins to be claimed that a fact is only a fact, a truth is only a truth, if the procedures for producing that fact can be followed by others. And there's a difficulty there. What if others cannot follow those procedures? Then what? A whole series of practices, traditions, and conventions are institutionalized in order to secure what we call replication. That's to say, copying an experiment done by someone else. We see the emergence of long-range, highly complex, very profound networks of traveling scientists who move between each other's workplaces in order to learn specific techniques in experiment, in the use of instruments, in the use of machines. The great questions of industrialization and of the market are involved there. For example, how do I know in advance that I'm using the same kind of equipment as you? Answer, I buy my instrument from the same shop. So the growth of Europe-wide, worldwide systems of trade in machines and commodities goes along with the growth of the sense that what I know because of what I've seen here must apply everywhere and in principle anywhere. The same is true for the problem of trust. One has to know in advance that the person who's telling me a story about a strange plant that grows in the East Indies, or a strange stone from South America that glows when you rub it, or a strange star seen one night from an island in the water between Denmark and Sweden. One has to know that the person who's telling me that story is credible, has credit, is trustworthy. So there's an intimate relation between the network of social trust, it's a social institution, the network of commodity production, of machines, foodstuffs, botanical objects, animals, plants, and the network of persons, of reliable individuals whose credit is high enough that one can believe what they say. And that's what's happening in the institutions of European science in the 17th and 18th centuries. A system of severe accreditation and of the social production of trustworthy people, trustworthy machines, and hence trustworthy facts. During the 17th and 18th century, I think what we see is not unprecedented. That is to say, obviously, before then, there had been vast imperial systems that had gathered and accumulated at their centers knowledge, information, goods, commodities, and peoples gathered from vast areas of the globe. The Chinese example is the most important and the most obvious, but there are many others. But I think what was new was the entanglement that the Europeans deliberately engineered between a political and economic reality, which was the gradual and then accelerating rate of exploitation and of accumulation in the 17th and 18th century, new global systems of loot, effectively, and the production within Europe and elsewhere of centres of accumulation and analysis for distributing, profiting from, analysing and describing this loot, these commodities, these collections of animals, plants, minerals and other phenomena, and on the other hand, the way in which the Europeans integrated that into vast systems of global knowledge. In other words, the globe itself becomes an object subject to knowledge. It's been argued by some historians that what we see in the late 16th through the early 18th century is the emergence of something like a planetary consciousness. I'm not sure that's right, but I think what is right is that some of the projects that we identify with colonial and imperial programs contribute to and are based on unprecedentedly intense notions of knowing the globe. Two very good examples are the expeditions launched from this city, from Paris, in the 1730s, one sent to the Arctic, to Lapland in northern Sweden, the other to Peru in the Viceroyalty of New Granada, part of the Spanish Empire, in order to conduct exquisitely difficult astronomical measurements of the length of 1 degree so that the shape of the planet could be described with extreme precision. Now, what those expeditions involved was action at a distance, or so it was claimed, that equipped in the right way, with the right machines, using trained people, in close, sometimes intimate collaboration with indigenous and Creole people, one could know the globe as a physical object with its own particular shape. And that was a remarkable program. It was controversial. Voltaire says in a very famous verse to one of the leaders of these expeditions, "You have found in a very boring place what Isaac Newton knew without leaving home." And that, it seems to me, captures a really important aspect of the new planetary consciousness. The other aspect, or the other episode rather, that we might pick out from that period in the 1700s, an episode of enormous consequence for ecology and environmental knowledge, is the development by the great Swedish scientist Carl Linnaeus of a system of naming of plants and animals and minerals that could be extended worldwide. So a scientific expedition to determine the shape of the planet and a scientific machine to determine the names of all the inhabitants of the planet. Now, it's wrong, it's absolutely wrong to exaggerate the efficacy of that system. So Linnaeus does exaggerate the efficacy of that system. What he says is, I have invented a system of naming plants so that from now on, it's a beautiful expression, from now on, every plant, even plants from the East Indies and from the New World, will speak its own name. The idea of this planetary consciousness that European scientists developed is not just that it would be global, not just that the globe would become an object of knowledge, but somehow using new machinery, new kinds of social techniques, new names, new centres of accumulation, botanic gardens and museums, the things themselves would be made to speak. And they didn't. They didn't speak. There was a permanent crisis of reconciliation between what was claimed at the centre and what was known everywhere else. There is no such thing as a single, simple, universal knowledge in this period. It's a constant struggle to maintain coherence and integrity between different kinds of knowing, different kinds of groups of people, natives, foreigners, others, servants, know things that the scientists don't know, or claim to know things that the scientists believe are false. There's a constant struggle to reconcile the idea of a universal, uniform, global science with the recalcitrant and irreducible system of many different forms of knowledge. And that remains, it seems to me, a fundamental site of almost permanent struggle, conflict, reconciliation, diplomacy, precisely. I'll give you one example because it's a beautiful one. Right through the 17th and 18th century, European naturalists spoke of a strange plant that lived in what is now Indonesia. This strange plant, they said, was poisonous. Really, really poisonous. It was called the upas tree. It was so poisonous, the European naturalists said, that it killed everything for 20 or 30 kilometers around. Birds flying through the air would drop dead from the sky. The poison, so the Europeans believed, was used on darts through blowpipes that the local rulers of Indonesia used to resist European invasions. Now, what's fascinating about this story is that the first people who wrote it down were the Europeans. And then at the end of the 1700s, French and Dutch and British scientists arrived in the East Indies, looked for this poison tree and could not find it. So they said, this is an example of a native superstition. We have shown with our universal scientific tools that the natives are ignorant and superstitious because they've always believed in this strange poisonous tree. Actually, the truth is all the other way around. It was the Europeans who more or less invented the story of the poison tree, and then when they found that it was false, they attributed the error to the natives. There are constant struggles to define the properties of an environment which is intrinsically heterogeneous. And current notions of traditional environmental knowledge and campaigns and struggles around biodiversity constantly run up against the troublesome diplomacy of the local and the universal, of the particular and the general. Are they superstitious or are we wrong? Are we right or are they trustworthy? Are we the experts or are they the experts? Once you define who the experts are, you are simultaneously defining the properties of nature. It seems to me that for a very long time in the European tradition, the model of nature that European theology endorsed is riven by very interesting and no doubt fundamental forms of contradiction. One obvious contradiction is that for an extremely long time, a traditional model of nature, which could well tolerate the idea that nature is a machine, also argued that nature is the source of value. So that for plebeian, working, artisan, peasant traditions, the idea was that nature, through God's action, is a source of bounty, of surplus, and that the surplus that nature produces is therefore a kind of divine blessing. Now, under those circumstances, plebeians, the workers, peasants, and so forth, rationally resisted the idea of imposing on nature's agricultural bounty the principles of political economy. It's argued by the major historians who've studied these protests in the 18th and 19th century that what was at stake in riots about the price of grain or bread, for example, was a defense of a view that nature's surplus and nature's bounty should not be a source of profit because it came from divine creation. It came precisely naturally. Now, those ideas are constantly being reorganized by different versions of the theology of nature as profoundly benevolent, of nature as not the source of social order, but rather constantly standing over against it, as though virtue is not to be found in the socialization of nature, but in the naturalization of society. And that's what we call romanticism, it seems to me. The romantic worldview, the notion of nature as recreation, or rather recreation, which is massively present for many European intellectuals, but also for large political forces from the late 1700s onwards, builds itself up out of the idea that nature is a kind of correction, caution, counterexample to the ills and crises of the social. Now, what's fascinating about that is that, of course, this does not by any means undermine the status of the scientist, of the savant. Quite the reverse. Because the most expert people who can speak for nature and in a fascinating way against the ills of the social are nature's spokespeople, and they are the scientists. So figures like Johann Goethe, Hans Christian Ørsted, and many other great romantic intellectuals, poets, philosophers, and scientists are not at all opposed to the regimes of the sciences. On the contrary, they invest in technique, in instrumentation, in the study of nature, in the identification of its profoundly important properties, so that those properties can be incorporated within the human order more properly, more adequately. Here in France, for example, as has been recently argued by a series of brilliant historical studies, the whole of the Romantic movement grounds itself in a fascinating way in a technological series of utopias, in a way of recreating the social order so that it matches the nature, and that matching will be achieved through a better, different, revolutionary technological system. Figures like Henri de Saint-Simon, Charles Fourier, the notion of the phalanstère, all of that, as has been argued in recent very important study, all of that is based within, simultaneously, romanticism and machinery. We think of those as being at loggerheads. In fact, they get on with each other extremely well, and they still do. it seems to me, finally, that there's a profound lesson for us in this kind of work, which is a romantic ecology may well suffer from bad faith, since it will persistently wish to define nature as everything that is not human. And in so doing, it cuts away at its own politics by reproducing exactly the great bifurcation that founded the modern sciences in the 17th century. There is nature, there is humanity. They are entirely separated from each other. What is natural must be walled around so that the humans stay away. And that builds an obstacle to human engagement and human presence inside ecology, which I think is still a great difficulty for a lot of environmental politics. I think there's absolutely no doubt that, at least in many of the European traditions, the idea that if a claim is natural, it is therefore morally powerful, so that to speak on behalf of nature is to be a moral agent, that originally comes from a range of ideas associated with creationism. If nature is the system through which the divine speaks, then speaking on nature's behalf or with nature is speaking on behalf of the creator and with the creator. And what has to be faced up to is where a kind of secular naturalism fits into that story. It's easy to see how what in English is called natural theology underwrites a highly moralized claim that nature is the ultimate source of value. A bit of economic history, I think, helps here. In the 17th and 18th century, it was argued that nature was the source of bounty, it was the source of surplus, and therefore it was not just a crime, but a sin to profit from changes in the price of natural goods, like corn. And those forces that defended that kind of natural theology also defended the idea that nature is profoundly the source of economic value. Not labor, nature. And I think that idea underwrites a great deal of current ecological thinking, with its critique of the labor theory of value, with which one might sympathize. But it seems to me substituting a critique of the labor theory of value by an assertion of the natural source of value, that politically is a very weak move unless one also rethinks and reworks models of nature. One has to, in a weird way, but I think a profoundly interesting one, go back to what the claims of natural theology were. In the early 19th century, for example, that is absolutely the issue, simultaneously at the heart of proletarian struggle and the new sciences of nature, of proletarian struggle, because Thomas Robert Malthus, parson, economist, professor, was arguing from the 1790s that nature is against us as humans, that nature cannot provide and will not provide for surplus humanity. That already at the end of the 1700s, one has a kind of prophecy of Gaia, that the planet will not support human activity at this rate. Now, what's fascinating is that many of his ideas were taken up by the radical working class. And the radical working class in Britain agreed, nature does not care for us, and therefore we must make our own fate. So there's a struggle within the first industrial society in Britain between viewpoints which have enormous resonance now in terms of green politics. At exactly the same time, famously, Malthus is read and used by a very wealthy English gentleman who'd trained as a medic and as a priest. He decided not to do either of these things, who was good at hunting and shooting and fishing, and who traveled the world and Britain studying nature. His name was Charles Darwin. And his use of the argument that nature will not provide for population is the theory of evolution by natural selection. You would not get to Darwin's great theory unless you had two ideas about nature in mind simultaneously. One, nature cares nothing for us. You must believe that. But you must also believe another thing, which is when we look at nature, what we see is adaptation. Now, both those ideas come from natural theology, a theology which argues that nature is incapable of, and in fact hostile to, the support of population. That's a theological idea in Darwin's upbringing, and the idea that what we see in nature is beautiful adaptation of means to ends. That has to be explained, and it's explained by nature's ferocious hostility to population. And it was Darwin's genius was to bring together those two, it seems to me, profoundly theological ideas into one secular theory. So on the one hand, a precedent for modern ecological debate in working class readings of the claim that nature doesn't care for us, and at exactly the same time, often in the same cities, this forging of a new science of a hostile but beautiful natural world. And that gives us essentially contemporary biology and contemporary ecological politics. So current debates about climate change highlight with unusual clarity, it seems to me, the relationship between global knowledge and trust. We're told that we live in an unusually, if not unprecedentedly, skeptical age, an age in which there is no deference towards experts. My view is exactly the opposite. It's not that we don't defer to experts, it's that there's a vast number of experts and it's extraordinarily hard to choose between them. If we look at the debate about anthropogenic climate change, we see this very clearly. The physical and chemical effects of greenhouse gases were already being studied and understood in the 1850s in Europe. For example, in the work of John Tyndall, great Anglo-Irish physicist, radical, agnostic, professor of science in London. And in 1859, he demonstrated in public, using an extraordinarily ingenious apparatus, the effects of gases like water vapor and carbon dioxide on the retention of heat by the Earth's surface. So we now look back at those experiments as some of the first public demonstrations of how the greenhouse effect works and the identification of greenhouse gases. Now, what's absolutely striking and I think profoundly important about what Tyndall was doing was that he was doing these experiments while simultaneously making a public for science, defining that public and defining the relation between his science and that audience. Tyndall was a devoted mountain climber, one of the inventors of one of Britain's rather strange hobbies, which is alpinism. And what he wished to do was to bring the Alps to London. So in a series of brilliant experiments, he reproduced in public a whole series of phenomena involving ice, glaciers, sunlight, gas, all the phenomena that interested him about what was happening in Switzerland, which he could produce in his own laboratory and which he produced on stage. And his aim was to produce a public, an audience, that would trust the relation between what he showed them and what was happening hundreds of miles away in the Alps. So the production of the first experimental greenhouse effect by Tyndall is simultaneously the production of some of the first scientific audiences in a lecture theatre and then the larger public of the mid-19th century. Now, I think what that tells us profoundly about the current debates, if that's what they are, about anthropogenic climate change and the greenhouse gas effects, is that to produce a credible set of pieces of evidence is simultaneously to work hard on the production of shared communities of trust, of shared kinds of public. That sounds utopian, it's deeply practical. It seems to me that one of the great crises is exactly the idea that to speak is to be convincing. It's necessary, it's not sufficient. Tyndall and his allies were extraordinarily powerful political actors and said so, and I think that's what's required now. The current debate on whether we are living in the Anthropocene period, and if so, when did it start and what are its implications, is fascinating and it's crucial. It has two, it seems to me, profound effects. One is that it draws undeniable attention to the reality of the fact that humans who might think that nature is the decor of history, that is, as it were, it's the scenery on which the fundamental acts of the human drama are played out, may be wrong. And that this is a series of enterprises and practices that have produced, in fundamental ways, what they only pretend to represent. It seems to me that's a fascinating aspect of the definition of the Anthropocene. And to trace those debates, to take part in them, even if one is no expert, seems to me to be extremely important. But it also raises the question, of course it does, of periodization. It was in the early to mid-19th century that European scientists began in an unprecedented way to turn what had been biblical periods into geological, physical periods. And the way those periods were defined used two kinds of evidence. One was evidence from paleontology, and the other was evidence from technology. So on the one hand, the whole of Earth history was going to be defined stratigraphically by layers in terms of an idea of ineluctable succession. And as the best historians of geology have taught us, what was happening there was the application of principles from the human sciences to the natural sciences. The source of the very idea of geological periods is the writing of human history. And it was the expert writers of human history, the antiquarians and the chronologists, whose techniques were then transferred by the great geologists and naturalists of the early 19th century to the whole history of the planet. And I think the Anthropocene is therefore a moment at which the relation between human knowledge and knowledge of humans is absolutely on the agenda. The second aspect, which is very striking, is that even human history itself has, more or less, since then, been defined in terms of technological development. So the notion of the Stone Age, which is the last few minutes, as it were, of this long history which is now being discussed, already defined periods in terms of the technologies that were being used, stone, bronze, iron, and so on. And the debate about when the Anthropocene began, with the Neolithic Revolution, with the coming of industrial production, with the development of nuclear power and nuclear weapons, is a way of debating the co-production of nature, society, technology, and expertise. And we have to have that debate. And if this is the way we're going to have this debate, that's great. Adaptation is a bad word. It has a terrible ancestry. It was the fighting word of social Darwinism. And what that meant was that social Darwinists argued that there is nothing humans can do or should do to resist, re-engineer, challenge, or alter their fate. And their fate, so it was argued, came from nature. So the best one could do was to adapt to a force that is greater than us and that cares nothing for us. That was the argument. And it seems to me that that notion of adaptation is still in play in a lot of public policy debates about anthropogenic climate change around themes like mitigation and adaptation, because the claim is fatalist. The claim is that there are forces which we, whoever we are powerless to change, so we have to adapt to them. In other words, a dualism between the force and the resource is insisted upon so that a limit is developed between what can be done and what should be done on the one hand, and what will nevertheless happen on the other. And that fatalism, it seems to me, at all costs, cannot be accepted. And it's the Anthropocene, precisely, that shows us that it should not be accepted. Because rather than using the vocabulary of adaptation, one needs a vocabulary which simultaneously registers both kinds of responsibility. Responsibility is a much better word to think with, because on the one hand, it means it is due to us, and on the other hand, it means taking care. And that relationship between responsibility as source and responsibility as moral and technical agent, there, it seems to me, is where the debate and the practices need to be focused. So I think there are new kinds of planetary consciousness and geoplanetary practice which both are emerging and have to emerge, in contrast with what historians have called the planetary consciousness of the 17th and 18th centuries. In particular, what the history of the sciences demonstrates beyond any argument whatsoever is that the production of the global and of the planetary is always also the production of particular kinds of community. One cannot take for granted the use of the word we in these debates. It's a word one should treat with extreme suspicion, because it either assumes that there already is a universal collective, in which case, bluntly, the problems have already been solved, or it assumes that tiny groups of interested parties already speak on and act on behalf of everyone and everything else, in which case, once again, the problem is already solved. What's necessary precisely is to attend to all the ways, complicated, difficult, time-consuming ways, in which something like a group of effective collectivities can be made. And since what the history of science teaches us is the solution to the problem of knowledge is also a solution to the problem of social order, if those techniques for producing effective collectivities work, they will also involve the production of effective techniques for responsibility. Responsibility, I insist on the point, in both senses. In terms of durable, as they say in French, in terms of a kind of sustenance, but also responsibility in terms of causal chains. Who is it? What is it that is in action here? Answering those questions practically answers much of the crisis that is now in play. So when I reflect on our future, partly that's a personal question. I think about my daughter. I think about what she will do, what her life will be like. That is to say, I'm thinking about the next 7 or 8 decades. And for her and her friends and her world, I have to, and I do remain profoundly optimistic, because I see enormous investments in optimism, energy, reason, activity, commitment, engagement. And those are the resources of hope. And at the same time, I guess this is a professional answer. As an historian, and above all an historian of the sciences, my attention is constantly drawn by Frederick Jameson's famous remark that it's easier now, apparently, to imagine the end of the planet than to imagine the end of the economic system that dominates the planet. And there again, I feel optimistic, because I feel that that is about to be inverted, and that in the near future, frankly, it will be easier to imagine the end of this economic system with all its consequences than to imagine the end of the planet with which we live.